Welcome class, and thank you for joining me for our final notes of chapter 4. You've made it through the whole thing. So today we are going to continue our conversation on complex numbers. And in our last notes, we talked about adding and subtracting these complex numbers. Today we are going to move into multiplying these complex numbers. Now, I want to draw your attention to the fact, remember that if I equals the square root of -1, that means if we were to square both sides, we get I squared, and then that I squared would equal -1 because squaring would cancel that square root. So one of the big concepts for today is when we're simplifying complex expressions, realizing that if you ever see an I squared, you should be substituting -1 in for that. So for example, I want to draw your attention to this problem right here. 3i times 7i. So we take the 3 times 7 to get the 21 that's there. Then I times I is I squared. But now what do? Well, we take that I squared and we substitute it with -1. So 21i squared all of a sudden becomes just -21. So one of the big things to remember is you should never ever have I squareds in your answers, okay? Whenever you have something written in complex form, you should only have the real part and the I part for the imaginary part. You are never going to have I squareds. So let's take a look at multiplying these things. So there's two ways to multiply them, just like there's really two ways to multiply polynomials. We can distribute and we can FOIL. So distributing looks like this. So 3i times -5 would be -15i. 3i times 2i would be 6i squared because of the I times I. Now, remember, that I squared right there is -1. So really we're talking about -15i, then 6 times -1, which is going to be a -6. Now to write this in an actual complex form, remember the -6 is written first, then the -15i. So that would be how we want it officially written. But again, the biggest key here is realizing that I squared needs to be switched with -1. Now, looking at foiling. So you know foiling for polynomials. Now we can also use foiling to simplify this multiplication of complex numbers. So F for first. 2 times 4 gives us 8. O for outside. 2 times 5i is 10i. I for inside. -3i times 4 is going to be -12i. And L for last. -3i times 5i. That's going to be -15i squared. So the first thing I notice is I can begin to kind of simplify some of this. 10i minus 12i. That's going to be a -2i. But then also remember this I squared sitting here. Remember that is a -1. So we have -15 times a -1. So really that turns into a +15, which gives us our last piece that we can combine. We can combine the 8 and the 15 to give us 23. To leave us that as our final answer. So again, two processes that you already know, you've seen when it comes to polynomials. Now we just have to apply it to this new concept, apply it to these complex numbers. All right. So the last little snippet on the front sheet here. Complex conjugates. A plus bi and a minus bi are called complex conjugates. They're special because they multiply to be a real number, meaning they can be used to simplify quotient expressions. So this is going to be something important when we're talking about division problems. We're going to use these complex conjugates. Okay, now, you may be wondering what that looks like. So, the first thing that we're going to do, I've kind of broken down each of these division problems into a step-by-step process. Now, the first step for each of them is just identifying what would the conjugate be. So, I'm going to work on this problem first. So, the first thing that we're going to do is multiply top and bottom by the complex conjugate of the denominator in order to simplify. Now, 3i is really 0 plus 3i, correct? So if we want the complex conjugate of that, again, the complex conjugate means you flip the imaginary part. All right, so instead of 0 plus 3i, its complex conjugate would be 0 minus 3i. So really, the complex conjugate is going to be a negative 3i in this case. So once you've identified that piece, the second step, multiply top and bottom of the fraction. So we have a fraction, 9 plus 12i over 3i. And now what we're doing is we're going to multiply top and bottom by that negative 3i. All right, so on top, you can see this is now turned into a distribution problem. So on top, I multiply that. Negative 3i times 9 is going to give us negative 27i. Multiply to the next term, 12i times negative 3i, negative 36i squared, over 3i times negative 3i is going to be a negative 9i squared. All right. Now, for the next step, recall, we don't want I squareds in any piece of our solution. So, because there's I squareds there, I see I squareds here and here. I'm going to switch those out with negative 1s. To get that. So, because of that, what we end up having, negative 27i, then a plus 36. Then on the bottom, negative 9 times negative 1 is a positive 9. Well, this actually fully simplifies. Negative 27 divided by 9 is a negative 3. 36 divided by 9 is 4. And now, final step, remember, if we want it in actual complex form, that means we're going to want to write these in the other order to get that. But notice what ended up happening is now there's no imaginary numbers in the denominator anymore. So think back when you had to do that with square roots. You had to rationalize the denominator. This is kind of the complex version of that. So let's go back up and work through another example. So 2 divided by 1 minus 4i. So looking at this, the first thing we want to identify is what is the complex conjugate of the denominator. So Instead of 1 minus 4i, we flip it to 1 plus 4i. Remember, to find the complex conjugate, you're just taking the opposite of the imaginary part. And now it says multiply top and bottom of the fraction. So, to give myself a little bit more room, I'm going to erase a little bit of that. So, we have 2 over 1 minus 4i. And now we're going to multiply that by the 1 plus 4i. 1 plus 4i. We're going to multiply by the same thing, top and bottom. So along the top, pretty simple. That's just distributing. 2 times 1 is 2. 2 times 4i is 8i. That's pretty simple. The bottom, though, the bottom is now a foiling process, okay? It's kind of 2 binomials down there. So we get our first terms, 1 times 1. We get our outside terms of positive 4i and negative 4i. And then last, which is going to be a minus 16i down there. Or sorry, I squared down there because of the negative 4i times positive 4i. All right, now we need to start simplifying this. So, looking at that, well, the top, there's really nothing we can do at this point. However, I want you to notice what happens on the bottom. We have 1 and then 4i minus 4i. Notice what happened because of the complex conjugate. Notice it cancels out those i's. And then another critical thing to see, that I squared up there is going to be replaced with a negative 1. So really we have 2 plus 8i over 1 and now plus 16, or essentially 2 plus 8i all over 17. So that's what it looks like as a single fraction, or if you'd like, you can also break it up and show it like that. Either way. So that's what this process looks like. And again, it can get to be quite a long process. However, as long as you remember these 3 steps, it'll get you to the right answer. So before we end our video, I do want to go through one more example just to make sure that we fully understand how to go about this process. So the first thing we're going to do, you need to identify the complex conjugate of the denominator so you can multiply top and bottom by it. So the complex conjugate in this case is going to be 3 minus that 4i. It's the opposite. So we're going to multiply top and bottom by that 3 minus 4i. Now, this example gets to be a little bit longer because you are foiling top and bottom in this case. Now, when you foil on top, 5 times 3 is 15. 5 times negative 4i is a minus 20i. Negative 2 times 3 is a minus 6i. Negative 2i times negative 4i is a positive 8i squared. And now we foiled the bottom. 3 times 3 is 9. 3 times negative 4i is a minus 12i. 4i times 3 is a positive 12i. 4i times negative 4i is a negative 16i squared. All right, so I've FOILed it completely out. Next thing that I want to do is I'm going to start combining my like terms and getting rid of my I squareds. So on top, notice I have negative 20i minus 6i. That's going to give me a negative 26i. Then also notice I have that I squared there. So I'm going to switch out that I squared with a negative 1. On the bottom, I have my 9. And now, negative 12i plus 12i ends up completely canceling out. That's the point of the complex conjugate, is you should see that pattern always happen in the denominator. It should completely cancel out. And I have another I squared. So I'm going to switch that with a negative 1. All right, so we're nearly there. So 15 minus 26i, and now we have a minus 8 there. And on the bottom, we have 9 plus 16 now, because of those negative 1s. So we have 7 minus 26i on top, and on the bottom, we have over 25. So you can leave your answer as that, or again, sometimes you'll see it represented separated out. 7 over 25 minus 26 over 25i. You'll see it represented both ways. So I know this can be a lot to take in with this multiplication and division, but please make sure you have all of the notes written out, and then we will do some more practicing in class tomorrow to make sure that it really sets in. So again, thank you for joining me, and make sure you have all of this written down.